I'd like to revisit the requirements discussion that was begun last time, and so some of this is going to be a review and some of it's going to be new since we didn't get all the way through it. One of the things we talked about is that initially we fill out a request form and it goes through a steering committee. The idea gets reviewed and you determine if you should look at it closer. If you decide that you should look at it closer, you go through different types of feasibility studies. One of the key important ones is an economic feasibility, which answers the question, should we build it? Does it make sense? Are we going to, in essence, turn a profit if we do that? And if it makes it past that, if the outcome of that gets reviewed by a committee and it still looks good, then you go and you start on the project. And so this section is about the analysis phase. It's also called requirements gathering. So although you had a high-level idea of what you wanted to do before, now we need a really, really detailed and, if possible, complete understanding of what we need to do as part of our project so that when it's finished, we don't miss anything. Alright, so another way of looking at that is in the planning phase. We had a system request, we did our feasibility analysis, and here in the analysis phase we're doing multiple things. We could be creating lists of requirements, items that a system must have in order to meet the needs that we have for it. And we could also have graphical models, including these called functional models, structural models, behavioral models. The idea being that after that these models are done, then you go on to building it architecturally. So, and what that means is programmers, if they know what they're going to build, can create diagrams that help them communicate with one another how they build the guts of that program. But the analysis phase is more about the business side of things, like how does a business person understand how the system works, which is a different mindset than the design phase, which is a programmer really thinking about how do we build this. Okay, one of the ways that you could look at solving a business problem as it relates to an information system is you would look at the system as it currently is, identify areas that it could be improved in, and then put together a list of things that you'd like to see in a new system. And I've mentioned in the past that that's kind of what that's really what you're doing in your class project, looking at an existing system, which is a big process with lots of sub-processes, and you're looking for ways that it's got problems and could be improved upon, and then you recommend how it could be better. And in this case, I would say the requirements are probably going to be graphical in nature in terms of describing how it could be done better. In other cases, other projects, you might just be able to make a list of things that you want. I mentioned these are 6 activities that happen as part of the requirements activity. They're kind of spread on the page here, not very neatly, but they're all good things. You're gonna, as you look at any particular problem that a business has, you're going to need to gather lots of information about that problem, and from that you're going to be developing functional and non-functional requirements. So we'll talk about those more in just a second. You may be developing graphical interfaces and maybe in PowerPoint or some other tool that allows you to express and share how you want the new system to look, what the input boxes are like. And then of all the things that you come up with, you might not be able to do all of them, and so you would prioritize them. And after you've gone through a set of interviews with people, and you've written down or created graphical models of what you understood, you're going to need to go back and evaluate with the users, with the stakeholders, what it is you did, because you may not have captured correctly what they do, and oftentimes there are revisions that come up from that process. Maybe they decide that they left something out, and it's a lot easier to have that discussion once you, for example, have a nice diagram showing how it is that they do their work. Okay, here's the definition of requirements. They're all of the capabilities that the new system must meet. So if you are going to create a like a website where you sold pet supplies, for example, you'd write on there things like your list of requirements would include things like my website it needs to accept credit cards, it needs to look um, like a friendly pet website as opposed to a business website or a lawyer's website. It must be fast, and you could even describe how you want your information presented, so that maybe a certain number of products are displayed on every page, or maybe you just want text names of your products, or maybe you want giant pictures with small little taglines of what it is. You have to decide what it is that you want, and you just make a list of all those things. All right, if you look through the slide deck that I will upload, there's lots of funny videos that I've put up there. We watched at least one of them in class. Okay, differentiating between functional and non-functional requirements. Let's look at the words in red at the bottom. So a functional requirement is designed to be an activity, or it's described as an activity or process that the system must perform. So you're looking at this from the business user's standpoint. If you're creating something that helps solve one of their problems related to accounting, for example, then all of the functional requirements are going to be about accounting. On the other hand, we have non-functional requirements, which describes operational characteristics related to the system. So these are, techie nerdy things. So, imagine for any IT project, there's a business side, something that supports an accountant or a supply chain person, and there's an IT side, the nerdy side. So the functional requirements, the word functional in this case refers to functions that the business person does. And so a regular person or a business person, all the requirements are just functional requirements are things that that person does. On the other hand, with non-functional requirements, these are things that nerdy people care about. So we have things like performance requirements, usability, like it maybe supports people with vision problems, or people that are blind, or people that are deaf, or people that are colorblind. It could have security requirements, maybe not as big of a deal if it's an informational website, but maybe if it captures credit card information, that needs to be considered. So those are all just technical things that a programmer would worry about, that you'd know, hey, this could be a problem if you don't do it the right way, but it could potentially apply to a lot of different products that they build, and they're going to make sure that gets built in. Whereas the functional requirements, that's going to be more closely tied to a specific functional role that a person has as an accountant, as a lawyer, and the things that they do. So some of the examples you have here are a functional user might maintain customer info, or maintain product inventory, order processing, billing, management reports. So it's maybe a little hard to get your brain around that, but this is really functionality of the system as it relates to the user's perspective, not from the programmer IT guy's perspective. Alright, I'd shown you some some requirements from UCO before. So we have here at UCO a website which we call it our portal. It's the main website for our university where you can log in and get access to the other services. And so if you're a student worker versus somebody who works in a finance office here, you're going to log in and you're going to get access to different applications and websites within the university's suite of applications. So the portal is meant to be a one-stop login to get to whatever it is you need as a stakeholder related to UCO. And so in an early version of that, they created this list. So it says portal requirements, and they identified them as functional requirements here, again meaning things that have significance to people that actually use the website. So just regular people as opposed to IT people. So you see things like, well, we want it to have support payroll, and we want it to support Bursar, and we want it to support digital measures, things that you don't use but I as faculty do. We want it to support the Learning Center, so D2L. We want it to support enrollment in My Courses. We want it to support chat functions. We want it to support the central image of the week. So they just went on and on with what they thought were the key things that it had to have. And then they mentioned how they wanted a different category of how they wanted it laid out. This is not the way that, so some visual aspects to it that almost um, sounds a little bit more functional. But if I jump into it, I see things like well, customizable. Yeah, so I think in this case that still is a user issue. Like, they want to be able to customize the interface. So at any rate, they had a lot of different requirements here that they were brainstorming on initially, and they actually had some other pages early on that says technical. So maybe these would have been more non-functional requirements that they were going through, and things like must be able to authenticate into Banner, must use open APIs, must support the login system called CAS, must support SSL encryption. So hopefully this gives you an idea of how IT people, in terms of non-functional requirements, are looking at things that it has to have versus what it needs to have from an end user standpoint. Next. All right, transitioning on to some other things. We have this diagram here, which is a different way of looking at things than some of the other diagrams that I've used. Sometimes we go just from left to right with that planning, analysis, design, and implementation. In this case, we have a different perspective, which is in the upper left, review the business case, meaning you're looking at a business with a problem, and you follow this thing around, and eventually you get back to the blue box, where I would say one way of looking at this is, after your analysis, you've put together documentation related to perhaps the before and the after, so that you have an indication of what you want this thing to do, particularly from an end user standpoint. So the documentation that you create on your project looks at how it is now. You do diagrams for how it should be in the future, including in your report you're going to put in screenshots of how new interfaces might look and things like that once you add IT to processes that don't have IT. So a combination of diagrams showing process flow as well as screenshots of what a new system would look like. That would end up in that blue box. But there's a number of steps that you go through before you get there, and one of the things that's highlighted here are 3 different types of UML models. So Unified Modeling Language, this is what we're going to start up in our next set of classes, showing you how to create models that can be used both by business people and by software developers to describe a system. So, and actually in the analysis phase we'll use UML models for describing things from a business person's perspective. In the design phase we'll use UML models, the same ones but with a little bit more technical detail in them, to look at the same system issues but from a technical person's perspective rather than a business person's perspective. Okay. And just as a preview of what those diagrams are, in the upper left we have a use case diagram which fits the classification of a functional diagram. And if you recall, we keep using this word function. Again, we're talking about things that an end user needs to do. So this is a diagram with little stick figures, and we see these little circles in here, or ovals, that indicate functions that need to be performed by a regular user within the system. Another diagram we have on the right hand side upper corner is the class diagram, and this class diagram it captures information about the data that's going to be represented by your system. So if you were talking about a warehouse, for example, you might be different aspects of your warehouse might be equipment in the warehouse, there might be orders, there might be order line items, these different issues could be related, these are different entities in the business environment that are going to have properties associated with them, and you're going to diagram those and show their relationships to one another. And so each of those items in the business environment that you're describing is called a class. And so the abstract term for that is a structural diagram. And then lastly, we have this idea of we have a sequence diagram, which takes the same idea of the entities that exist in the business environment, and it gives you details about the type of information that needs to be passed back and forth between those items. And so we use a different type of one type of diagram to show how what the entities are in a certain business process and how they're related to one another. And then we use another diagram called a sequence diagram to show how the details of what data specifically gets passed between those things. Not just that they have a connection at one point or another, but what's the data that they pass back and forth. And so the high level abstract term that we use for a sequence diagram, which is an example of a behavioral diagram, is behavioral diagrams. Here's a snapshot from the book which shows the mapping, previews the mapping as we're going to go from analysis diagrams with UML to design diagrams with UML. Like I said before, most of the time we're just going to be taking the same types of diagrams we learned for analysis, and we're going to add more detail to them when we are looking at systems from the programmer's standpoint. So on the left hand side, with the analysis requirements perspective of a business user, we have use case diagrams, use case descriptions, which are not visual but actually written, at least the first one there. We have class diagrams of a certain flavor. We have sequence diagrams, and then we're not going to do state chart diagrams, but for any of those we see arrows going on to the right hand side, and so we'll see that let's see, for example, the domain class diagram becomes a design class diagram. They're still class diagrams, it's just a class diagram with different details. We see that the sequence diagram becomes an interaction diagram. Again, it's just going to be a diagram with more detail in it. And that covers the most important parts there. I guess the use case diagram also contributes to the interaction diagram from the programmer's perspective. Okay, so stepping back for a moment away from the UML diagrams, let's focus on this box that's highlighted in red. If you're looking at if there's a business problem or situation that exists, you can think about it how you might deal with that problem in 3 different ways. So imagine that maybe the way that a doctor's office does its ordering of supplies is really poor. It's done poorly. There's for whatever reason they don't stock things well because they don't track what they have electronically, and they want to do something that makes that whole process better. There's a few different main approaches that could be adopted to handle that. The first one would be business process automation, and that's the easiest one. The second one is a little bit more rigorous and challenged, and that's business process improvement. And then the third one is business process reengineering. And I'm going to stop there and pick this up in the next video so that I can cut it in 2. At least the class I'm going to cut in 2 is what I mean.